And we learned how to plot a line. We knew, of course, we refreshed ourselves of how to plot a line. Such that if we had a line like, I don't know, 2x1 plus x2 less than or equal 5, how we would do that? By creating that t for x1 and x2, and finding the intercepts, and then plotting them based on those values. 5 halves, then connecting those, creating the line, and then to make sure to identify the solution, we use the arrows on the line, and in this case we plugged a test point, which in this case it was 0, 0. So 0, 0 was less than 5, so 0, 0 is included in the solution of that line, which is that direction. That's where these arrows came from. We are now going back. We're now going back, and we say, if I have a line like that, how would I write the constraint from that? If I had something like this, how would I write the constraint from that? Of course, you're all familiar with this. You can use the slope of the line. Based on the slope of the line, you can write general equations, and many of you are familiar with this sort of writing the equation of a line. And follow that line if you are comfortable with that. If you know how to do that, follow that line. I show you an easier way. But you don't have to do this, the method that I show you. Do it the way that you are more comfortable. The way that I do it is, it's exactly what the formula does, but I do it in a simpler way. I count how much on the x2 value I have. And this is plus 2. Plus 2. That's how much I have on x2. I will multiply that number by x1. I will count how much value I have on x1. I will multiply it by x2. 7 plus 7, x2. Then I will multiply these two values together. 2 times 7, 14. That's plus 14. I put the signs in there such that you make sure that you're clear on what we are doing. The missing right now, the equation, if I put an equation there, that's the equation of the line. Missing is what is related to these arrows. It is telling me that this is the solution. So I find a point inside my solution space and test that. That test has to be true. If it is inside the solution space, that test has to be true. This is inside the solution space. So if I plug 0, 0, it has to be True. 0, 0 is less than that. So this sign is that. If this is easier for you, do it. If it is not easier and you would like to find the slope by y2 minus y1 over x2 minus x1, and then multiply that by whatever it is, mx plus b and all those things, do it. Please do it the same way that you are comfortable with. These are the lines that look like that. What happened if the arrows were the other direction? Nothing in here will change. Only this will change. Because if the arrow is pointing the other direction, when I plug 0, 0, the result has to be false, which has to say 0 is greater than 14 if the arrows were the other direction. So let me do a few of these lines that are different. Let's do this. 2 minus 3. Two and minus 3. See if you can write it yourself. I will write it here, but see if you can write it yourself. Write it yourself, and then look here. Okay? That's minus 3 minus 5. You asked a question or you were stretching? Okay. Here are 4 examples that I did on the board. It's quite easy and it is very quick. It's very quick. But again, you can do it any way that you like, as long as you come up with the answer, you are fine. We are going to make sure that everybody is clear on keep no negative on the right hand side. Simplify, reduce when possible. No decimals. Keep no fractions. Based on this little guidelines that we have here, what am I supposed to do with these four things that I have? Raise your hand. Yes, ma'am. First one. I have to multiply them by a negative value. So that would be negative 2x1 plus 3x2 less than or equal 6. This is not what I report. This is what I report. What else? Anything else I have to do? You have to do the same thing for line 4, which is 5x1 negative 7x2 less than or equal 35. Okay? Thus, that's what we have. Now we will look at some special lines. We'll look at some special lines. An arrow on this line. L4, L5. What is L5? X2 is greater than or equal to 0. That's my L5. What is that arrow? That's L6. X1 greater than or equal to 0. That is L6. L7, a vertical line. The vertical line is x1 greater than or equal x1 is, he says it is x2. Is it x2 or x1? It's x1. x1 greater than something. x2 greater than something is that way. 1 greater than. What is it greater than? -3. Do you keep it like that? So you say minus x1 less than or equal 3. That is my L7. L8. What is L8? That is L8. It's a very simple process. Based on these, what is the feasible region? Make sure that we are clear on where the axes are. I'm going to just color them differently. That's where X1 and X2 axes are. The last type of lines that we are interested in are the ones that pass through the origin. The ones that pass through the origin we can't do this with. This easy approach doesn't work with those. But we know that it is passing through the origin, and we do need to have another point or a slope, whatever is given to us. If a slope is given, then we write it based on the slope. If another point is given, we will still do it the same way. So if a line like this one, if a line like this one is given to you, someone needs to tell you what the slope of that line is. Or there has to be a clear, specific point that you can read the coordinates from. So let's say that we had this identified for us. Let's say that it was identified for us as 1 and maybe 2. Of course, that's a negative 2. If it was identified like that, you could actually calculate the slope, or just by the definition of a slope, rise over run, you can do that. But don't forget to have the signs of the values also included. So what is the slope of this line? Rise over run is the x2 value over the x1 value. So m in this case is negative 2. And use x2 equal mx. mx1. So your x2 is equal negative 2x1. Move everything to one side of the equation. That would be 2x1 plus x2 equals 0. That's the equation of the line. That's the equation of the line. And if you have arrows on them, you can't test 0, 0. You have to test something else. Okay, I can't test 0, 0. Let me test 1 and 0. 1 and 0 is 1. What is the relationship of 1 with 0? It's greater than. So this will be greater than or equal 0. And we call that line L9? L9. Did the solution of space change? No. It remained the same. Feasible region remained the same. You said you wanted a line that goes this way, and we will do a line that goes that way. And this time we're going to give you a slope, and we will tell you that that slope is, that's L9, that's L10. And we will tell you that the slope is 1/3. There you found the slope. This time I gave you the slope. So you look at that and you say, okay, x2 equal mx1, x2 equal 1/3 x1, 3x2 equals x1. It would be negative x1 plus 3x2 equals 0. Plug a point. This point, 1 and 0, is in the solution space. 1 and 0, that is negative 1, and relationship with 0 is less than or equal. So this is what that line is. x1 plus 2x2, 6, and the sign is less than or equal. Minus x1 plus x2, 0, and the sign less than or equal. And then on this line, and then on that line, you would have x1 less than or equal, let's make it a little different, 2.5. We don't keep it like that. We will have 2x1 less than or equal 5. That's the L3. L5 and L4 are x1 greater than or equal to 0 and x2 greater than or equal to 0. They remain here as x1 greater than or equal to 0 and x2 greater than or equal to 0. Are we done? Now you're done.